Hi everybody, Dr. Pingle here. Welcome to part 4 of our lecture on terrain. Today we're going to be talking about 3D representations of terrain and metaphorical terrain. So basically visualizations that sort of look as if they're an actual physical object, and extensions to that where we imagine other things like population density envisioned as if it were terrain. So before we get started, I want to try to take a quick look at 3D terrain models in general. We've talked about these before, but just as a reminder, a digital elevation model, or DEM, is the foundation kind of data structure of most of the visualizations that we're going to look at. Again, DEMs can be any sort of digital elevation product. So TINs, or triangulated irregular networks, are one example of this, but most of the time, and from this point here in this lecture, we're really going to refer to these mainly as rasters. So in that case, with a DEM as a raster, each cell has a number. Those might be floats, meaning that they have decimals in them, or they might be integers. So the SRTM products, for instance, Shuttle Radar Topography Mission, has integer values that represent elevation at each point. That doesn't necessarily make a difference for the visualization itself, although it can sometimes, again, as we've talked about, make a difference for the container that those go into. What we want to do today is talk about some visualizations of that information. So one kind of common approach is to use color to represent what those numbers are, and the color map that we use can vary. It can be sort of a standard elevation kind of a color map with kind of white and then brown, yellows, and then kind of blending down into greens for lower elevations. But a hypsometric color map can actually be just about anything. So you can go from kind of dark representing kind of low-lying areas to white representing higher areas, which is actually a default when you first load in DEM into Arc, or anything else. There's really no set in stone kind of color map that has to be used. So we have a lot of flexibility there. But we can also use things like hillshades and other visualization techniques to represent those DEMs to bring out more detail than just color. And in fact, a hillshade, or even a multi-directional hillshade, often adds more information than just the hypsometrically tinted one. And we might well combine those two things together to make a better visualization in general. So while we might use to color to represent elevation, there are a lot of kind of nice things that brings to the table. So if you look at this image over here on the right, even without a legend, you can probably figure out what the high areas are, what the low areas are. So we've got dark green representing kind of the lowest lying elevation, kind of blending into a green and then kind of a yellowish color, and then kind of brown, purple, and white up at the top. And it's fairly easy to see that. However, if I asked you to draw a line across that, as we've done here, and imagine what that elevation profile looks like, could you do it? And the short answer to that is yes, you could certainly make a good attempt at this. But in a lot of cases, as we'll see, the metric information can be lost. So you might very well know that as you move across this line from left to right, you kind of move down into kind of a valley area where the river is, and then back up again, kind of continuing across maybe kind of a planar feature, and then kind of up the mountain before you go back down the other side of the ridge, and then back up again. The sort of general pattern is easy to see, but if I asked you how far above this from the plane is it relative to how far below that, you might well have a hard time answering. If you want to solve this problem, you can actually use tools in GIS to do this quite easily. So this is the profile tool in ArcGIS. It's a really easy tool to use. You can load that up, and I would encourage you to load a DEM of your choice up and give that a try. You can basically draw a line across. You can load linear features like road networks and calculate profiles that way. In this case, from left to right, you can see the profile graph output profile below it. And it's pretty easy to see how that matches up. Again, as we're moving left to right, we kind of dip into that valley, back up again, and you can sort of see how those things go. And this is a zoomed in version of that, just to make it a little bit clearer. So when I say that color information doesn't transmit metric information accurately, what I mean is that even though you can get the sort of general idea of whether the terrain goes down or up, it's actually fairly difficult to quantify that, even when you have a legend, but especially when you don't have a legend. And of course, the way that people actually use maps is they kind of consult the legend to get a general idea, and they move back and forth. But as we've talked about, we want to minimize the need for the map reader to need the legend at all. Ideally, in a perfect world, we wouldn't need it. And so even though you have this general pattern, it can be difficult to say how much higher is this point than that point. You know that it's higher, you might know that it's lower, but by how much is difficult, and that's what we mean by the ability to transmit metric information. So one of the really nice features that's now packaged with ArcGIS Pro is the ability to insert local and global scenes into the project. Here we're looking at a local scene that's been added. What that lets you do is sort of add everything as if it's a planar surface. And once you do that, you can rotate the view. So it starts off looking normally, but once you use the mouse, you can start to actually rotate that image in place. The other option, as you'll see there, was new global scene. Global scene would produce a similar kind of a visualization, much like Google Earth. The control in the lower left may look a little bit strange. What this lets you do is kind of fine-tune exactly how you're rotating and moving through the scene. I tend to use a mouse to do this, but if you don't have an external mouse, then that little element on the lower left really gives you some good control over what you're looking at. If you zoom in, you can really get a sense of the 3D-ness of the image. That's hard to see when you're far away. Remember that the Earth is actually quite flat. But as you add some vertical exaggeration, the relief will pop out to a very good extent. That's actually pretty easy to do. All you need to do is click on the ground feature. It can be a little bit hard to find, but if you click on the ground feature under elevation surfaces on the left menu, and then click appearance, there's a vertical exaggeration that you can then apply to bring out a good deal of detail. And so this is adding up to, in this case, a 5 factor of vertical exaggeration, which makes the Blacksburg area really kind of pop out in a more realistic way. One of the really nice features is draping. So that's kind of what we've been looking at here, just not really called that. Draping is the process of taking any imagery, whether it's a satellite image or a map or a drawing, and placing that on top of the terrain and looking at it. Technically, this isn't 3-dimensional, it's 2.5-dimensional. 2.5-dimensional in this case means that what we're looking at is a surface, that there isn't the ability to add more than one point at a given XY coordinate. However, even so, this is quite an amazing way to experience the landscape, and particularly it can really bring to life a lot of old maps in a way that is hard to get when they're just two-dimensional. What I'll do is I'll post the link to that. You can see here down below. It's very Googleable, but I'll also post a link to this in the course software page with the lecture, so you can watch this. I'd really suggest pausing the video now and taking a look at that so that you can see exactly what I'm talking about. This is a really nice representation of sort of bringing old Washington, D.C. to life using these techniques. Looking at kind of historic imagery is actually one of my favorite ways to experience this kind of draping idea. To do that, you can get a hold of historical topographic maps is a really good way to do that. These are pretty easy to find. This is the Esri portal, but the USGS has its own portal online. These actually kind of tend to move around a little bit. I think the links were provided in one of the previous lectures, but they're very Googleable. If you look for USGS historical topo, you'll go right to one or both of those sites. Many of these are browsable directly in the web browser, and then you can download whatever it is that you want. There are actually similar websites for accessing historical imagery. One of my favorites is Historic Aerials. This is an attempt by a private company to kind of go back through libraries of historic aerial photographs to try and make those available to the public. The advantage is that the library is actually quite good. The disadvantage is that because this is a company that's been doing it, you do have to purchase these. But even so, that may be less expensive than trying to find these on your own. Some of these come from public sources, some of them don't. So there's not necessarily a guarantee that everything that you see here you can find for free. Although that's not a bad instinct if you are interested in some of these things, kind of looking around in the public sites may be a good idea. This is an example of what you see when you're using historicaerials.com. Most of the usefulness of this is going to kind of go away by the fact that it's sort of watermarked heavily. But even so, you can get a pretty good idea of what's underneath here. What I'm going to show you here is an example of a historic Washington, D.C. topographic map added in here. So this starts out as easily as bringing in the, in this case, it's a geotiff of the scanned-in topo map. We load it in there, it's already geo-referenced, and so it's going to appear exactly where we want it to be. So here it is brought into, and again, I call it ArcScene, sort of an old habit. This is really just a local scene view inside ArcPro. This is the historical topo map right here. As you kind of pan around, you don't necessarily see a whole lot, and so one of the nice things to do is to add some vertical exaggeration to any of these kinds of maps. So again, going on ground, going to appearance, and then adding in some vertical exaggeration. In this case, I'm adding it up to 10, which is pretty heavy vertical exaggeration, admittedly, but it does give you a pretty good sense of what's going on here. And as long as you sort of keep in mind that this is quite exaggerated, it can be a good way to see a lot of the subtle features that would be difficult to pick up without the vertical exaggeration. ArcScene is actually quite powerful. So not only can you drape imagery on terrain, but you can actually add real three-dimensional objects in here. In this case, these are a couple of simple examples, some arrow kind of icon-based stuff at given XYZ coordinates. You can add trees to a scene. You can take building footprints and extrude those upwards, which means you sort of just bring them up from wherever the footprint are. So you're not rendering the true shape here, but it's often an okay approximation. And you can add fully fledged three-dimensional models in here as well. You'll get a chance to do this in some of the notebooks that accompany the lecture. One of my favorite ways to use these kinds of tools is actually to visualize non-elevation data. So in this case, what we're looking at is an attempt to visualize accumulated snowfall by virtue of an animated hillshade map. That hillshade is actually supported by some color information as well. Some hypsometric tinting here to go along with it. Not your usual color scheme. But this is kind of a fun way of experiencing snowfalls as mountains of snow. Obviously, we have to apply quite a bit of vertical exaggeration to make this work too. But it's still kind of a fun way to look at this stuff. This is a project that I did a couple of years ago. I wanted to create a 3D printed model of Hurricane Irma, which is the one that kind of plowed over Puerto Rico a couple of years ago. These are actually surprisingly easy to make, so I'm not going to show you the 3D printed model today, but I'll show you how to render these things in ArcPro to get a sense of the shape of the hurricane by intensity value. This is Hurricane Irma. If you don't remember, this was from a couple of years ago. It was a Category 5, so a very major hurricane that caused quite a bit of damage to Puerto Rico before coming close to the mainland United States. This is some of the data that I used for the project. So I use Mesonet, at Iowa State University to gather some of this data. The radar imagery itself is distributed, in this case, via an HTTP site. And all I did was just sort of look at the timestamp for the hurricane when it was near Puerto Rico, locate those slices that I wanted, and then download them. The radar imagery itself came in as a PNG, which is a useful way of archiving integer-based geodata. So the radar returns are actually keyed to an integer value. And then the WLD file is a world file that provides the georeferencing information. It tells me where that image actually goes on the Earth's surface. Now, technically, probably a PRJ file or a projection file might be helpful here, but you can always add that later. This is an example of taking that imagery and rendering it. So the very first thing that I do is remove those 0 values so that that becomes transparent and we can kind of see the shape of the hurricane a little bit more clearly, and then applying a different color map here to get a better look at it, and then remasking those zeros off as no color. So this by itself is a pretty good start, but then what we can do is we can add that image itself again as an overlay, and in other words, as a ground surface. And essentially what we're going to do is remove the terrain as a ground surface. We're only going to use that new stuff as a ground surface. Now, obviously, that's very flat. It's not a true ground, and those intensity values don't have anything to do with actually a vertical structure. So to make this work, we have to kind of hunt around for a vertical exaggeration that provides the appearance that we want. And once we hit 100, we start to see some structure here. And if we crank this up to 250, we actually get a pretty good sense of what that looks like as a whole. Again, totally arbitrary. You can kind of set that to whatever you want, but this provides kind of a nice looking appearance. So what else could you visualize this way? So this is what we just saw was an example of taking non-spatial information and visualizing it in the third dimension. So taking intensity values from a hurricane and representing that as if it's a Z value. What else could we do? There are actually a number of good examples of this online, and I try to save these and bookmark them as they come across my desk during the year. These are a few that I've seen recently. This was an example of US population distribution imagined as sort of vertical blocks. So using that vertical scaling here. I'm not a big fan of the legend. 1.5E7 is a little bit opaque for most users, but it's still quite a nice representation of the data. This is another one for the UK. In this case, again, we're visualizing population as mountains. It's a very, again, effective way of seeing these things and making it a little clearer. Again, color obscures a lot of these relative comparisons in exactly the same way for thematic maps as it does for topographic maps or terrain maps. And so by adding this sort of fake third dimension, we can really make it easier for people to compare the relative heights and to sort of say, well, how much bigger is the population of Manchester than Liverpool? Here, it's quite easy to see that it's something like twice as high. There were a number of really good things that have come across my desk recently. This is one of my favorites. This is the topography of wealth in Los Angeles. This is kind of a story map that's presented here with the URL below. I'd encourage you to pause the video and take a look at this one when you get a moment. The visuals are really pretty stunning. You can see one selection of those here at the right, imagining the height of the terrain by monetary value, and you can start to see sort of the towering heights of Beverly Hills. Really a fun way to experience this kind of a layer. And of course, you can imagine that you could just as easily 3D print this stuff as well. And when we get to that unit, we'll talk about that. This is one of my favorites. These are Japanese land values. This is fun because it uses a hexagonal binning to aggregate, which is also kind of a unique way of looking at the data. In geography, we're really used to using rasters to do this. But hexagons are kind of a really fun way of doing it too. And here we're just scaling the height of the hexagon column according to the land value. And then to close out, one of my favorites, here you can see what the Waffle House density visualized by height. Again, just kind of a fun way of communicating this stuff. Not everything needs to be super serious. This is again, adds a lot of interest, even if Tufte might call some of this stuff chart junk, and maybe it is. But it also has a lot of curve appeal, which can be important if you want to get eyes on what you're looking at, as well as the actual advantage of making it easier to make these comparisons between height. So with that, I'll wrap things up. Again, I encourage you to look at some of these visualizations on your own. The Washington, D.C. reconstruction particularly is a short 6 or 7 minute video. And then some of these extra ones here at the end you may want to play with, particularly the topography of wealth in LA is a pretty good visualization. So with that, thanks, and we'll see you next time.